Welcome everyone, and thank you for joining today's Auxis Corporate Performance Series webinar, diving into Amazon Web Services, what you should know and how to derive the greatest benefit from them. My name is Yaslin Arroyo, and I'm the moderator for today's webinar. Today's webinar is presented by Auxis. Auxis is a unique consulting and outsourcing firm comprised of former industry professionals who don't act like traditional consultants. Offering a customized, real-world, results-oriented approach, we become ingrained in our clients' culture and vision and truly dedicated to their success. Our depth of experience allows us to maintain a focus on customization, flexibility, and bottom-line results at a very competitive cost structure. At this point, I'd like to introduce our featured speaker, Jose Alvarez. Jose Alvarez is the Director of the IT Managed Services Practice for Auxis and leads our IT outsourcing and solutions practice. Jose has extensive experience with large multinational companies delivering best practices. His expertise includes IT strategic planning, cost control programs, emerging technologies, IT operations, and infrastructure management. Before we begin, let me remind all participants, we welcome your questions. Please feel free to submit them in your webinar panel at any time, and we'll address those questions at the conclusion of the webinar. And with that, I'll turn it over to our speaker, Jose Alvarez. Jose?
Thank you, Jocelyn. Good afternoon, everyone, and thanks for joining us today. In this presentation, we will do a quick review introduction on how cloud technologies are driving data sharing and growth. We will then talk a little bit about the facts regarding Amazon Web Services and their position in the industry as an infrastructure as a service provider. After that, we'll talk about some hints that you should know before moving to AWS. These items that will highly impact your implementation. Then we'll explore some of the AWS most important services. Know that some companies don't use even half of this, but they're there and some of them are free. So they should be considered during your implementations on the AWS cloud. And lastly, we will go through AWS Security, which is an important topic for some of you as well as a concern for some of you. So with that said, let's get started and let's start with the introduction. Information sharing is growing at a very high speed. I don't know if you know, but in the last minute, there were about 204 million emails sent. This means about 42 emails per every human being per day. There were about 20 million photo views and about 3 million uploads on Flickr. 61,000 hours of music listened on Pandora. About 100,000 tweets. And about 6 million view and 277,000 Facebook logins. So more importantly, 80% of the world's data has been created in the past 2 years. And cloud technologies has had tremendous impact on supporting this growth. So with cloud technology, we have access to everything all the time from any device and from anywhere. And this is what cloud technologies bring to the table. On the next slide, we'll talk about the Gartner's report regarding technologies that you cannot afford to ignore. This slide shows the top 10 strategic technologies areas for 2012 and their evolution on 2013 and 2014. As you see, cloud technology has maintained itself as one of the most important technologies with some minor changes being introduced. But it's important to note also that there are new technologies being introduced, like client computing, reshaping the data center, security, which mostly is activity monitoring, flash memory, and mobile applications. Most of these items are very related with cloud technologies. Now, the adoption is shifting from private to public clouds. In the private cloud, the services are managed and provided within the particular organization. There are less restrictions on network bandwidth. There are fewer security issues compared to public clouds. An example is HP data centers. Then we have the public clouds, where services are delivered to the client via the internet from a third-party service provider usually. And a good example is Amazon Web Services, which we're going to be discussing on this presentation. But the trend is going to a hybrid cloud, and this is a combination of private and public clouds. An example is Biz Apps in private, sales, and also like email on a public cloud. They need for processing power on demand. Now we're going to go through Amazon overview, and we have a few slides to show some of the facts for Amazon and some interesting information that you should know. So Amazon has a long history of using a decentralized IT infrastructure. This arrangement has enabled their development teams to access compute and storage resources on demand, and it has increased overall productivity and agility. By 2005, Amazon has spent over a decade and millions of dollars just building and managing the large-scale, reliable, and efficient IT infrastructure that had powered their online retail platforms. So Amazon Web Services has been operating since 2006, and today serves hundreds of thousands of customers worldwide. Amazon.com runs a global web platform serving millions of customers and managing billions of dollars worth of commerce every year. They have about 51 CloudFront Edge locations. CloudFront Edge locations is a particular service from Amazon that delivers your web content closest to the end user. So if a user is located in Europe, then they have a point of presence there, and the content will be delivered over there and will be synchronized to whatever your data center is. Amazon has over 25 availability zones across 10 regions. Availability zones are basically data centers, and regions are specific regions within a particular zone or area. AWS S3 service has over 2 trillion objects, and S3 is their major storage service, which is used by most of the companies in Amazon today. AWS has over 5.5 million Hadoop clusters and over 40 different services that are used by a lot of their customers. All these services are a little bit different from other providers where you have to implement your own services or work with third-party vendors. AWS often offers 7 managed database services, including SQL, MySQL, Oracle, and DynamoDB, Redshift, etc. This is very helpful, so you don't have to build your own database server. You can just take advantage of using the AWS database service. Amazon EC2, which is their name for the instance or the server, is 62% of total Amazon spending. So when you go to the cloud, 62% of your expenses mostly will be into the instances, not into the other services they offer. Customers that spend less than $50,000 a year account for about 4% of the total spent on Amazon Web Services. And only 4% of the customers spend more than $1 million a year on AWS. Now, a couple of other facts is that Amazon, nobody knows exactly how many servers they have, but as of last year, there was an estimation of about 160,000 servers worldwide. There are 6 major advantages and benefits for cloud computing, and mostly related with Amazon. First one of all is you trade capital expense for variable expense. So instead of having to invest heavily on data centers and servers, before you know on how to get to use them, you can only pay when you consume those computing resources and only pay for how much you consume. You benefit from massive economies of scale. By using cloud computing, you can achieve a lower variable cost than you can get on your own. As I mentioned before, Amazon is a huge company. I mean, they have 160,000 servers, so that benefits end users to lower the cost of operations. And because they have hundreds of thousands of customers, which are aggregated in the cloud, these providers like Amazon can achieve a higher economies of scale. You stop guessing capacity. You eliminate guessing on your infrastructure capacity needs. When you make a capacity decision prior to deploying an application, you often either end up sitting on expensive idle resources or dealing with limited capacity. With cloud computing, this problem goes away. You can access as much or as little as you need, and you can scale up and down as required only with a few minutes notice. And in some cases, you can even do it automatically. Increase speed and agility. In a cloud computing environment like Amazon, new IT resources are only either a click away. This means that you can reduce the time it takes to make those resources available to your developers from weeks to only just a few minutes. At Auxis, we tried this a lot, and we do a lot of automation, so we can bring a whole entire farm of servers within a few minutes on Amazon. This obviously results in a dramatic increase in agility for the organization, since the cost and time that takes to experiment and develop is significantly lower. Stop spending money on running and maintaining data centers. So right now, we focus on projects that differentiate your business, not the infrastructure. Cloud computing lets focus you on other areas of support. Instead of focusing on infrastructure, now we focus on how to improve, how to manage it better, and how to improve security, how to do monitoring of security on real time. That is really how the management of the data center has shifted into. And then you can go global in minutes. You can easily deploy your application in multiple regions around the world with just a few clicks. That means that you can provide a lower latency and better experience for your customers simply and at a minimal cost. Now let's look at the Gartner's Magic Quadrant for Cloud Infrastructure as a Service. As you can see, Amazon is the clear leader in this particular area. Microsoft is moving up in the quadrant and will be a clear contender for AWS. We also expect Google moving up into the leader space very soon. Now, what would you use AWS for? How would you choose that, or why? First of all is if you require significant scalability offerings. Amazon is very scalable, and you can, as I mentioned before, scale up or down on your web or your application servers by just a click of a button or by doing it automatically based on some criteria that you specify. You can, if you desire to automate almost everything, Amazon is very good for that. As different as other providers, it allows you to do automation of creation of devices or deletion of devices. And this is something that you need to take advantage if you go to AWS. If you require local and global availability, which is true not only for Amazon but for most of the providers. If your business demands a robust application marketplace, and this is another differentiator from Amazon, Amazon provides you with a marketplace that you can select over 2,000 of applications and services right on the spot that you can get implemented into your particular platform. And the good thing about the marketplace is that all the billing gets implemented into Amazon, so you don't have to go to different vendors. It's all integrated into one account. If you depend upon the most robust feature set, they do have a really good feature set. As I mentioned before, they have over 40 services that are there and available for customers to use. Some of them are free, and they should be taken advantage of. And at the end, if you want to implement robust security, which these apply not just to Amazon but to most of the providers, although security is not just what the cloud provides to you. Security is also in the hands of the customer, implementing the particular tools and monitoring to ensure that there's no data compromise. Now, there are some other providers that I want to mention on the chart you saw before. You saw Microsoft Azure, but usually companies go to Microsoft Azure if you're deeply invested into Microsoft technologies and you require that particular integration. Also, if you can accept some scalability limitations, or if you're looking for a contingency plan for AWS. And lastly, if you wanna, if it really benefits you from a financial perspective. Now, we're going to go through some slides now that talk about what you should know about AWS before migrating. Some of them are technical, but this is important information that is not on every book. It's not out there. So we have collected a series of items that, based on our experience with implementations with Amazon, that people should be aware of, because these things may or may not delay your implementation. So moving to the cloud changes the way that you think about the IT infrastructure for sure. As everybody knows, on a regular data center, you have your fixed IP and you monitor your devices, and if something goes down, you bring it up, whether it's a physical device or a virtual device, etc. But some companies think that moving to the cloud is a very easy task, and it's not. There's a few things that need to be considered. This section will help us to understand some of these items that need to be considered specifically for Amazon. So we start with general tips. First item is you should scale horizontally. You should not have different type of servers that are larger in terms of resources. Instead, you should have smaller instances that are more reliable with a smaller amount of resources. If one of them goes down, it would impact your platform as much as if you have a bigger machine that goes down that will impact your particular application. Your application may require changes to work on Amazon, and this is a true statement. Some applications are not architected to work with this type of automation or this type of platform, so you need to look into your application and see if coming from a physical environment to a cloud environment makes sense for that. They might require some re-architecture of some modules or the application. Always be redundant across availability zones. So Amazon is counting on you to implement redundancy within your platform, and they make it easy for everybody. If you implement instances, if you implement load balancers, make sure that you implement it across multiple availability zones, which are data centers. Doing this implementation is very simple, as I said, and you should do that to almost every instance that you manage. For disaster recovery, used multi-region type of approach. So instead of having only just multi-zone, which are multi-data centers, do replication to other regions and have a disaster recovery plan. You can use Amazon, or you can use even another vendor. If you use another vendor, you will have to invest into some development and make sure that data is properly replicated and do a lot of testing. Be aware of AWS service limits before you deploy. This is a true statement. We have run into this situation a long time ago when we started our first implementations. There are various service limits that are enforced which aren't highlighted until you actually are trying to deploy your application and get the error notification. These limits can easily be increased by making a request to AWS support. However, some of them can take some type of turnaround time, and some of them can be just as easy as taking a few minutes for getting them done. Decide on a naming convention early. There's a lot of resources on AWS where you can change the name later, but there's equally a lot of them that you cannot change those names. For example, security groups. Having a consistent naming convention will help you self-document your infrastructure, but also avoid any mistakes by removing or adding the stuff that you're not really working on, that you're not intended to. Decide on a key management strategy from the start. This is important mostly from a security perspective. There are some questions that you should ask. Are you going to have a one key pair per group of instances, or you're going to have a one key pair to use for your entire account? This strategy needs to be in place before you even start to deploy your application. And then make sure that AWS is right for your workload. If you have a steady load and your servers are used 24/7, it might be possible that there are cheaper providers you can use, or maybe cheaper to use dedicated hardware on your own. One of the big benefits of AWS is the ability to scale up and down rapidly in response to load, but not everyone really needs this feature. There are some companies that actually run their loads during business hours, and at nighttime they bring down the resources and then they recreate them automatically in the morning. So this is kind of common for some companies as they have matured in AWS services. Let's talk a little bit about tips on identity and access management. This is mostly from a security perspective, but it's really important to have that clear. You should implement role-based access. IAM provides role-based access to AWS account regardless if you are running any different environments on the same account. Do not create any users with specific access. Instead, use those IAM roles. And you can add those users to the roles, which is a lot more secure. Lastly, Amazon provides multi-factor authentication. Some companies opt to ignore this particular feature, but this is a great security feature that adds an extra layer of security. This should be applied to every single user that have access to that particular platform. And basically, when you access the platform as an administrator, it challenges you with a different token that is running on your phone or your computer, and you need to enter that token, whether it's a virtual or a hardware device, to actually get authenticated. From an application perspective, you should not store any application state on your servers. This might sound a little crazy, but those servers are not going to be there on a permanent basis. If a server gets killed or if gets removed for any reason, you will not lose any application state. Sessions should be stored in a database. Logs should be handled via syslog and sent to a remote store. Uploads should go directly to an S3 storage unit. And any post-processing or long-running tasks should be done via an asynchronous queue. Store extra information in your logs. One of the common mistakes is that companies just log the basic information coming from certain devices. You should add additional information. This is important for you to do investigation, for do forensics, etc. So you may want to add like instance IDs, regions, availability zones, environments, etc. That will help you doing this type of debugging in the future. If you need to interact with AWS, you should use SDKs for your language. Do not try to roll your own. This is a common mistake also that should be avoided. The AWS SDKs are very, very well written. They handle authentication automatically. They handle retry logic, and they are maintained and iterated by Amazon. Also, if you use the EC2 IAM roles, then SDK will automatically grab the correct credentials for you. Have tools to view application logs. As I said before, a lot of the management and the monitoring has shifted to the security from the cloud. So you should have an admin tool. You should have a syslog viewer or something that allows you to view current and real-time log info without needing to SSH into a running instance. Needing to SSH into a running application instance to view the logs is going to be a big problem in Amazon. From an operations support, this is the craziest idea, but this is a lot of companies don't know this, but on a regular data center, you have access to SSH access to all your servers, and that's how you manage them. In Amazon, it's not. Actually, you should avoid to have SSH access to your web servers or application servers, and if anything goes wrong with those devices, there's a process that you should be killing that device and creating a brand new one automatically with no problem. So If you SSH into your servers, then your automation for Amazon has really failed. That's not the purpose. A transition for this is to disable SSH on your firewall on your physical data center before you migrate to Amazon, to make sure that people know how to react to that and how to actually troubleshoot these type of issues. Servers are ephemeral, as I mentioned before. You really don't care about them in terms of they can get destroyed at any time, but they can get recreated at any time within a few minutes. It takes no time, and it should be all automated. That's the beauty and the benefit of Amazon. Don't give servers static or elastic IPs. For typical web applications, you should put things behind a load balancer and balance them between availability zones, which are data centers. That will give you great redundancy. Automate everything. This includes the recovery, the deployment, failover, etc. Package and OS updates should be managed by something, whether it's just a bash script or a chef or puppet. As I mentioned before, everyone gets an IAM account, and never log into the master. Also, get your alerts to become notifications. If you set everything up correctly, your health checks should automatically destroy bad instances and spawn new ones with no problem. Instances. These are your EC2 service, which is basically your servers. One of the most important things is to use tags, because tags are given to most of the services, and they help you organizing and searching. They're also used to trigger behavior on the instances. Use termination protection for non-autoscaling instances. You're going to run into some instances that are going to be fixed. You're going to build them manually. If you have that case, then you should have this protection so nobody can get rid of them by mistake. Don't keep unassociated elastic IPs. And the reason is you get charged for any of elastic IPs that you have created but not associated with any instance. So make sure you don't keep them around once you are done with them. From a network perspective, use a VPC. VPC is your virtual private cloud. In Amazon, you have a choice to create your own environment, and this is what separates you from the rest. So you provide your own private subnet where your platform is basically isolated from everyone else. This allows you controlling the traffic at the network level using access lists for additional security. You can also set up egress firewall rules, which you cannot do on the actual EC2 instances. Implement security groups. Security groups is a new concept in Amazon that you don't see on most of the other providers. Basically, you can lock down the security of who talks to who. So you can have your web servers, a particular subset of them, only talking to a particular subset of databases. In that way, you don't mix and match these things, and you restrict the access. Elastic load balancers. We brought this up on this presentation because most of the companies, when they go to Amazon, use web farms and load balancers. And there are a couple of items that need to be considered. Amazon load balancers allows you to terminate the certificates on the load balancers. Adding that certificate there, remove extra processing on your instances. So that will improve the speed and the processing times. Pre-warm your ELBs if you're expecting heavy traffic. This is a little crazy because you don't do that on the physical data center. But it takes time for your ELB to scale up capacity. If you know that you're going to have large traffic spike, you need to warm up your ELB in advance by injecting a lot of traffic, or you can contact AWS, pre-warm your load balancer. RDS are basically your database services from Amazon. On a typical data center, you have as an example, you have a virtual SQL server, and that's where you run your database, or your Oracle server. Amazon gives you a service, so you don't have to create your database server. You basically get that service, and you just move your data into it on your tables, and that's your database moving forward. And they take care of a lot of the work. They take care of the patching. They take care of a few things. So with RDS, my ISAM tables are not supported. And what that means is that you can migrate your MySQL implementation, as an example, to Amazon to later understand that this is not supported, and the backups that you get from this particular service may or may not work. So be aware of that. Enable monitoring for all RDS events. So the good thing is that there are over 80 events that can warn you or inform you about any issues or tasks on your databases. You should take advantage of them. And for failover, if you're using multi-zone setup, this is one of the things that you might not think about, which ends up being incredibly useful when you need it. CloudWatch. CloudWatch is the monitoring service that you get from Amazon. And CloudWatch is very important because it's the way for you to know if something is going wrong. Some companies use CloudWatch, but they also use an additional third-party monitoring system just to add some other monitoring points that you want to add into your implementation. But from this particular perspective, you should deploy CloudWatch through recipes. And recipes are basically scripts that when you create an instance, you run the script and automatically deploys all your agents for monitoring without human intervention. You should take advantage of the free metrics that are offered by CloudWatch by Amazon. CloudWatch monitors all sort of things for free, like bandwidth, CPU usage, etc. And you get about 2 weeks of historical data. As I mentioned before, for longer than 2 weeks, you will need to have a third-party solution in addition to CloudWatch. CloudWatch also offers custom metrics, and if you want to monitor anything that is not covered by the basic metrics, then you can implement your custom metrics, and they can be integrated into CloudWatch as well. And lastly, use detailed monitoring. If you want to do this, you have to pay about $350 per instance per month in addition to, but it gives you a little more granularity because it gives you monitoring every minute instead of every 5 minutes, which is the default. From a billing perspective, just a couple of items that you should consider before going to Amazon. One is you should reserve instances to save in fees. So what does that mean is that if you keep in an instance or a server for 1 to 3 years, then you should reserve it to get a lower hourly rate. This will drop the cost. You don't need to assign a specific instance to be reserved. Rather, you specify what is the type and size, and any instances that match that particular criteria will get that lower price. You need to set up granular billing alerts. Most of the companies don't do that. They just wait to get the bill at the end of the month to find a surprise that the bill is really high. But you should have some alerts, and they should be coming up every so often. So you can probably set up some weekly, monthly, or even quarterly if you need to. But they will let you know instantly if you have a service that is consuming a lot of resources and is causing you a problem from a billing perspective. And lastly, perform a monthly billing audit. You need to go service by service. You need to see what is being used, what is not being used, and you need to go through the bill. This is important because the bill sometimes is a little bit confusing and it has a lot of information, but it is important to keep the cost down. It can get crazy. Next section, we're going to go briefly, very high level on AWS services, and although we have a few pages of those, we don't want to go in detail in some of them, but we're going to go with the ones that are really used today by most of the companies. So Amazon is a very comprehensive in terms of cloud services platform that offers a lot of compute power, storage, content delivery, and other functionality that a lot of the organizations can use to deploy applications and services very cost effectively. These services are trusted by the largest enterprises to power a wide variety of workloads, and that includes web, mobile applications, data processing and warehousing, storage, archive, and many others. This slide shows the classification of those services for this particular presentation. So we start with computing. And these three are really important this is the basis of Amazon. First one is EC2 that we've been talking about for the last few minutes. And this is a web service that provides resizable compute capacity in the cloud. It is designed to make web scale computing easier for the developers and system administrators, and allows you to pay only for capacity that is actually used. So if you use X amount of CPU or memory and you reduce that at a later time, you pay for whatever you use and for whatever hours you use. Auto scaling allows you to scale up and down the capacity that you have on your implementation for the EC2 instances. So with that, you can ensure that the number of EC2 instances you're using increase seamlessly during demand spikes to maintain that performance that you need, or decreases automatically during demands that go down. You define those rules on how you want to increase or decrease. And lastly is the elastic load balancing. This is really good feature from Amazon. They're very inexpensive. I think it's something around $18 a month or so like that per load balancer. And basically you can distribute those into different availability zones for redundancy. And they allow you to share the load between the different web servers on your farm. You can implement them, you can change the settings, and it's like working on any physical load balancer, but this is going to be a virtual one. From a storage perspective, I just want to mention a couple really quick. S3 is the most used storage type of service from Amazon, and S3 provides just a simple web service interface that can be used to store and retrieve any amount of data at any time and from anywhere in the web. Glacier is usually a very extremely low-cost storage service that provides secure and durable storage for data archiving and backup. In most of our customers, we use Glacier when we want to archive data after 3 months from S3. So we have our particular automation that says after X amount of time, move this data to Glacier to keep it there for 1 year, 7 years, whatever your compliance need is. And then lastly is AWS import and export, that basically if you need to do a migration to Amazon and you need to move a large amount of data, then you get a device, you send it to Amazon, they plug it into the network, and then you can perform that task seamlessly. From a database perspective, there's a couple of items. I just want to mention one of them that I think is the most important is RDS, which is the Relational Database Services. And as I mentioned before, they provide services for about 7 different types of databases. This is a very cost-efficient and resizable service, which gives you a lot of redundancy. With RDS, when you sign up for these databases, you can set up your backups, you can set up your maintenance windows, and where Amazon is going to use to actually do some updates or not if needed on the particular code. From a networking and CDN perspective, we have VPC, which we mentioned before. This is your virtual private cloud. You set up your environment all within your VPC. You can have multiple VPCs, one for production, one for test, one for development if you want. But this is how you protect yourself against external. You also have Route 53, which is a domain name system web service. And with Route 53, it basically answers any kind of DNS queries with very low latency by using a global network of DNS servers. So the queries for the domain are automatically routed to the nearest DNS server and answered with the best possible performance. You can also use it to manage your public records on AWS. CloudFront, we mentioned that as well. It provides you content delivery network. Basically, when you have a farm of web servers, you can have the content available closer to your user as possible. So if Amazon has a data center in Europe and you have a user in Europe, then that content will be replicated and make it available to that user as close as it can. There's a lot of services from analytics, and this is really good for the developers. I'm not going to go in detail in any of them, but I want to mention one that I think is interesting, and is data pipeline. This service came up in the last few months, and it helps you move data between AWS compute and storage services. So data pipeline is like your cron job on a regular data center. But this is a reliable service, so you define a pipeline, you define the schedule, you define what you want it to do, and basically it runs. But not only runs on a way that you know it's going to run, but it gives you some statistics and some information that it run and it performed the job. From application services, there's a couple of them that we can go through really quick here. One that we use the most on our implementation is SES, and we found this very helpful. Instead of implementing an SMTP email server to deliver email for the application or for users, etc., you can use this service, and this service will basically take care of that. It's highly scalable and is cost effective, but it provides bulk and transactional email sending service for the cloud. From deployment and management, this is mostly from the system administrator perspective. We mentioned and we went through IAM, which is the security access to your cloud. We briefly touched on CloudWatch, which is the service from Amazon that allows you to monitor your resources on the cloud. But there's two others that are really important. This is really the nature of Amazon. The first is CloudFormation, which is a service that gives developers and businesses an easy way to create a collection of related AWS resources and provision them in an automated way. You have CloudFormation templates that can be used to create your own resources, and by just a click of a button. OpsWorks, it's an application managed services that make it easy to deploy applications in the cloud. Basically, you script all your application steps, and with the combination of CloudFormation and OpsWorks, you can have a whole environment created within minutes. Lastly, CloudTrail. This is very good for security. CloudTrail is a service that enables security analysis, resource change tracking, and compliance auditing by providing a history of AWS API calls that are made via the AWS Management Console, the AWS SDKs, any command line tools, or any higher level AWS services like CloudFormation. So if you want to track, which you will want to track changes on your cloud, CloudTrail is a service to implement. Let's jump now into AWS Security. Because there's a lot of questions usually about this area. How secure is my cloud? So the security approach has evolved and has changed a lot. AWS provides a global secure infrastructure and foundation. In a traditional environment, developers and architects are responsible for everything related to security: facilities, physical security, physical infrastructure, network infrastructure, the virtualization infrastructure, operating systems, application, and even application account management. In AWS, they're just responsible for specific areas, and mostly is the operating systems, the applications, and the data. AWS customers are responsible for protecting the data, and this includes protecting the confidentiality, integrity, and availability of the data in the cloud, and for meeting a specific business requirements for information protection. One major misconception is that the cloud is secure, and when I move my platform to the cloud, I don't have to do anything. But as we said, the approach has shifted a lot. Now we're focusing into monitoring access, integrity, confidentiality of the data by implementing new services and products. So much of the security responsibility is moved out of the enterprise architect's hands. And as we said, although it's moved out of them, it focused now into the actual monitoring of new security services. And lastly, make intelligent choices in using certain tools for securing your applications and operating systems and data. As I mentioned before, Amazon has a marketplace with a lot of third-party vendors, software and services that you can use on your implementation, and a lot of them are used from a security perspective. Now, there's a couple of common mistakes on security, and we touch on some of them, but some of the companies are trying to replicate the same type of environment that they have in the cloud, that they have in the data center as they will have in the cloud. And in reality, that's not the case. The whole mentality, the whole infrastructure, the way that it's deployed and managed changes, and it shifted a lot. But if you're not automating often enough, then that's a big mistake. If you want to take advantage of the cloud, you shift in your management to make sure everything is automated, everything can be deployed using scripts or templates, and you're doing a lot of automation on monitoring, especially on security. Now, sharing security responsibility for AWS services. So AWS offers a variety of different infrastructure and platform services, as you have seen. For the purpose of understanding security and shared responsibility of these services, we have to categorize them into three areas. One of them is infrastructure services, where the customer manages the operating system. The next one is the container services, where Amazon manages the operating system. And lastly, there's the abstracted services, which AWS manages the underlying services components. Each category comes with a slightly different security ownership model based on how you interact and access the functionality. So let's start with infrastructure services. On this particular slide, you see on blue the areas that are managed by the customer, and you see in orange the areas that are managed by Amazon. This category includes computing services like EC2, where you control the operating system and you configure and operate any identity management system that provide access to the user layer of the virtualization stack. So on an EC2 instance, for example, you manage your access to the systems. As we said, we don't want SSH, but you can manage different type of access, and Amazon doesn't get into that. Amazon has some services that are under the container services category, and on these ones, typically they run on separate Amazon EC2 or other infrastructure instances. But sometimes you don't manage the operating system on the platform layer. AWS provides a managed service for these application containers, but you're still responsible for setting up and managing network controls, such as firewall rules, and for managing platform level identity and access management separately from IAM. The examples of this container service include Amazon Relational Database Services, RDS, Amazon Elastic MapReduce, which is EMR, and Amazon Elastic Beanstalk. In particular, RDS, as I mentioned before, when instead of you creating a server or an instance and loading SQL or MySQL or Oracle, you don't have to do that anymore. You select, I want a particular database service, and Amazon manages the underlying systems or areas into that particular instance. For example, they will manage the operating system, and if you selected, let's say, SQL or MySQL, and there's a new patch release for those, Amazon will manage the update of those based on the maintenance window that you have selected when you created that particular service for you. If you selected that you wanted to have it replicated to another zone, Amazon will manage that replication. If you selected that you wanted to be backed up, Amazon manages the backup. And if you set up your CloudWatch alerts, you're going to get notification when those backups have occurred. And the last one is the abstract services. So this category includes high-level storage, database, and messaging services, such as the Amazon Simple Storage Service, the S3 that we mentioned before, Glacier, DynamoDB, sets for email services. All these services basically they abstract the platform or management layer on which you can build and operate cloud applications. You access the endpoint of these abstracted services using the AWS APIs, and Amazon manages all the underlying service components of the operating system in which they have reside. So as an example, we mentioned S3, which is a storage. On S3, you will basically just create your buckets, your storage, and then Amazon will manage everything that is around that. You don't have to do anything but just either putting data, extracting data, or just the access of the data. Next, we're going to go through just a quick slide on some AWS security tips that need to be considered. Security is a big area for Auxis, and when we do Amazon implementations, we always have those into considerations because moving to the cloud has a lot of risk, and you need to make sure that you have covered all the aspects. So the first one is, and we mentioned some of this already, but you should use EC2 roles. You should not give applications an IAM account. If your application has AWS credentials backed into it, you're doing it wrong. One of the reasons that it's important to use the AWS SDK for your language is that you can really easily use the EC2 IAM roles. The idea is that you specify the permissions that a certain role should get and then assign that role to that particular instance. Assign permissions to group and not to users, and we touched into this a little bit. Managing the users is difficult. It is a lot easier to manage permissions by assigning them to groups, and you will assign users to the particular group that you want them to have access to. Use CloudTrail to keep an audit log. This is a great service from Amazon, and basically we log any action performed via the APIs or web console into any of the services. So you can send those logs into an S3 bucket, and then you can use those logs to be read by another tool of your choice to keep those logs for X amount of time and to actually do some investigation or search. And set up automated security auditing. So it is important to keep track of any changes on your infrastructure security settings. One way to do this is to set up a security audited role, but there's a lot of ways to do it via cron jobs, and there's a lot of tools and services out there for security that you want to consider as well. For example, you want to have some services that will monitor file integrity for your major application servers. You want to have services for intrusion detection, prevention, or just intrusion detection systems, etc. So there are a lot of services you can get on the marketplace from Amazon that you can use on your implementation. We're reaching out at the end of our presentation, and on our last slide, let's just go through some summary really quick. So first is cloud computing continues evolving, but it is one of the growing trends from IT strategic initiative from every single company. Every company is thinking, how do I go to the cloud? AWS is one of the strongest players in the market, and they provide a scalable, robust, and flexible cost model. But you need to do it right. You need to implement it right to take advantage of it and not get crazy with some of the pricing based on usage or the lack of use of particular services that are very helpful. Amazon, as different from all the other providers, they provide about 40 services that are there for you to use and make it very easy for customers to deploy their applications in the cloud. Now, on the other side, there are a few items that we discussed on this presentation that you need to consider when migrating to Amazon that can affect your migration plan. These items, they need to be looked at it in advance, and they need to be built into your plans. And lastly, from a security perspective, companies should now focus on implementing robust security solutions for the cloud platforms and automate security monitoring as much as you can, which is something that we do on Auxis when we do implementations of Amazon and cloud. We basically do the management of the cloud, but we also focus a lot into the security monitoring. So with that said, this is the end of the presentation. Jocelyn, if we can open up for the panel for any questions.
Okay, thank you, Jose. Yeah, there's one question here on what has to happen in order for AWS to consider an outage real and in violation of their SLAs.
Thank you. And this question is a little tricky just because the way Amazon considers a break of an SLA. In reality, Amazon is trusting their customers to implement redundancy and provide business continuity the way that you implement your platform. In a lot of the cases, there are customers that don't know very well how to implement Amazon, and they don't take advantage of the multi-zone or multi-region features or the replication of the backups. But as we mentioned before, you should not care about your web servers into Amazon. When you go to Amazon, those servers can get deleted, can get destroyed at any time. As long as you have your automation in place and you have multi-zone and multi-region implementation, you shouldn't have any problems. And that's what Amazon is counting on you on, to do that so you don't break any SLAs.
Thank you, Jose.
Do we have any other questions?
It looks like those are all the questions we have. So thank you, Jose, and to all of our participants for joining us today. Please watch for our follow-up email with the replay link along with a copy of this presentation. And also, if you would please take a moment to complete our brief exit survey, we'd appreciate it. And on behalf of Jose and the Auxis team, we thank you again and enjoy the rest of your day.